Hi everyone, my name is Serge. Welcome to Zamega Videos. If you're looking to build .NET applications using a mature, reliable, and performant database, which is also free and open source, then you should definitely consider the PostgreSQL database. In this video, I'm going to show you how to quickly create business applications from an existing PostgreSQL database using Blazor and the latest release of Zamega.net, which in addition to SQL Server has now support for PostgreSQL as well. If you like this video, make sure to hit the like button and leave your comments and feedback below. To be able to connect to your PostgreSQL database from Visual Studio using the npg-SQL provider, you need to install the npg-SQL PostgreSQL integration extension, in addition to the Zamega.net extension that we'll use to create and build our solution. Let's go ahead and create a new Zamega solution for our application in Visual Studio. With the Zamega.net extension installed, you can pick Zamega as a project type to select the Zamega solution template for our Blazor application. In the next screen, I'll set the project name as pg-SQL demo and just hit create. The next screen allows you to select and configure different technologies that you want to use for your Zamega solution. I'm going to select a standard Blazor application, which by default includes both Blazor Server and WebAssembly rendering modes. If you watch our other videos, you'll see that Zamega provides the same unified programming model for both of these modes. So for simplicity, I'm going to uncheck the WebAssembly and just use the Blazor Server mode. In the latest version of Zamega, the configuration of the project for business service implementations now provides a selection of the database type, which includes both SQL Server and PostgreSQL. So I'm going to go ahead and select the latter for our solution. I'll hit Preview to review our configuration of the selected projects, and then hit Create to generate the solution. The projects in our solution consist of EF Core entities and business services that are separated out for a clean architecture, a set of client projects that help you write reusable presentation logic, and a Zamega model project, where you can define your domain, service, and presentation models, and then generate the application code from those models. As I mentioned before, we're going to build our application from an existing PostgreSQL database. For this demo, I went to the popular website PostgreSQL tutorial and used their sample database for DVD rentals. It has a decent number of related tables, such as a customer or film, and also includes some features specific to PostgreSQL. I imported the sample DVD rental database to my local PostgreSQL instance, and we can use the pgadmin tool to browse and manage this database. For example, let's take a look at the film table. If you look at its columns, you can see that it uses some unique PostgreSQL features, such as the text array type for a multi-value column special features. The rating column uses a custom type MPA rating, which is actually an enumeration of ratings, like PG, PG-13, R, etc. The release year column uses another custom type, year, which is a domain based on an integer type with additional checks. The primary key field is film ID, which has a data type integer and takes its values from a sequence by default. However, this sample database has been designed in a pretty peculiar way. Even though the key columns in the tables have an integer data type, the data type of other columns that reference those is usually small int. For example, if we take a look at the columns on the film actor table, then you'll notice that both actor ID and film ID are defined there as data type small int. Yet, for each one of them, there exists a foreign key to the respective tables that have an integer primary key. I guess PostgreSQL allows it since small int type is compatible with the integer type, but I find it pretty weird, and you'll see the kind of issues it creates in a minute. Going back to our Visual Studio solution, let's try to import our data model from the structure of our sample database. Previously, you may have used the EF Core tool to scaffold the entities and the DB context. But let's take a look at how it will work for our database. Our entities will be in the pg-SQL demo.services.entities project. So to scaffold the entities, we first need to add the Microsoft Entity Framework Core design package to that project. Now I'm going to open the Package Manager console and run the .NET EF tool to scaffold the entities from our database. As you can see, it ran into a number of issues here. First of all, it cannot scaffold our rating field, because it's using an enum data type. It tells you to define a CLR enum first and then add that property manually. But more importantly, it choked on those foreign keys using different data types on each end due to the small int data type on the foreign key columns instead of integer, as we discussed earlier. Well, that means that using the standard scaffolding tool becomes problematic, because all those small int columns are also used by some views, and updating their data type to an integer is not that easy. Luckily, Zomega can handle these types of issues, as you will see in a moment. We'll start by importing the Zomega model from our sample database. For that, I'll go to the Generators node in the model project, expand the Model Enhancement folder, and open the properties for the Import from Database generator. Notice how it's configured to output the imported files under the Import folder by default. First, we need to specify the connection string for our sample database, which opens up a standard connection dialog. We automatically have the .NET provider for PostgreSQL, and the UI for connection properties comes from our NPG-SQL extension that we have installed. If you want to use a different provider, such as ODBC or OLEDB, then you can change it here. I'm going to fill in the parameters for our local sample database and hit OK. The next dialog asks if we want to save these parameters as a default for the entire model project, so that other generators could use the same connection info. I'll select yes, so the properties for our generator will just show Use Project Setting. If you check the properties of the model project, then you'll see that this is where the connection parameters are defined now. Next, I'll just run the Import from Database generator by right-clicking it and selecting the Generate option. As you see, it ran without any issues and added the model files under the Import folder based on the configured output path. Let's take a look at the model file for the film entity. As you can see, the Special Features field, which was defined as a text array, uses a logical type string list. The rating field that used an enum data type and the release year that had a domain as a data type also have special logical types created for them in the model. The film ID field is marked as a serial key and has a dedicated type film, which extends from the integer key base type. Should any field in another object use that film type or its subtype, it will automatically define an implied foreign key reference to the film entity. So for each field of type small int that has a foreign key to a primary key of type integer, such as the language ID, the import process has defined a separate logical type, language small int. If we go to its definition, you'll see that it extends from the language key type to keep the foreign key relationship to the language entity, but overrides the database type to be small int. The type MPA rating was created to extend the enumeration base type. It also references MPA rating enumeration that was created for the possible values of that database type. And the logical type year has a base integer type, just like the year domain in our sample database. Now that we have imported our Zomega domain model from the sample database, let's build a few screens for browsing and editing some of those domain entities. Note that this process is not specific to PostgreSQL, but equally applies to other databases such as SQL Server. The common way to do it with Zomega is to define CRUD service operations in the model, which allow you to create, read, update, delete, or search your entities. Then, for any view that you want to define, you can identify operations that are used by that view and construct its view model from the input and output structures of those operations. This allows Zomega to generate standard search and details views without you having to manually build such views. Let me demonstrate this by building screens to search, view, and edit customers and films. To streamline this process, Zomega includes a model enhancement generator that allows you to add CRUD operations and set up both search and details views for any entity. All you have to do is to select the files that you want to add it to, right-click, and then run the full CRUD with views generator under the model enhancement menu. If we go back to the film file now, you'll see that we have our CRUD operations, the search and details views, and some data objects that serve as view models for those views and are based on the CRUD operations. To generate all the code artifacts from our model, all you have to do is to right-click on the model project and select the build menu. This will run all generators that are included in the model build. You can actually see which generators have been run in the output window. Now let's build and run our solution and see what kind of screens we get generated by default. Our solution template has set up all the infrastructure to secure the app using a password-based login screen. However, for the ease of development, it had the username and password pre-populated with some default values. So I'm just going to click the login button, which will take me to a rather empty home screen. If you open the sidebar, you'll see that our views have been generated under a generic views submenu, since they are defined in a default module without a name in the model. If I click on the film list menu, we're going to get a screen that allows us to browse the films from our database. On the left, there is a search criteria panel where you can specify your criteria for the search. By default, it just has all fields of the film object. If you click search, you'll see all films displayed in the paged results grid, which also displays just all film columns by default. Down below, it shows the total number of records returned, which is 1000, as well as the number of records currently displayed in the grid. The criteria panel was automatically collapsed when you ran the search, but you can open it back up and change your search criteria. For example, if we want to show only films shorter than an hour long, we can set the length criteria to be less than 60 minutes and rerun the search. You can see that the total number of records went down to 96, and all of them have a length less than 60, which means that our criteria worked correctly. The summary of currently applied criteria is displayed above the results grid. Keep in mind that this screen filters records with this criteria using a database query, instead of retrieving all the records and filtering them on the client, which would be quite inefficient for large tables. You can also use a different grid control that has its own additional in-grid filtering and search, such as one from Syncfusion, which will further filter the current results. The results grid allows you to click on any row and open up a details screen, where you can view and edit details of the film or delete it. Notice how it shows the text array for special features as comma separated and uses proper controls for editing different types, such as the date and time. The details screen is also full of essential features, such as marking required fields with a red asterisk, validating fields, and showing when the data has been modified. It even created a drop-down list for the rating enumeration based on the values that it imported from the corresponding database type. If you try to close a modified view, it will prompt you about unsaved changes to minimize any accidental data loss. If you remember, we also created CRUD operations and views for the customer entity. As with the film screens, by default the customer list has columns for all the fields of the customer object, but that's not quite what you want to see on that screen. We can drop the extraneous active column because we already have the active bool column displayed as yes/no. We can also get rid of the last update column and have it only on the details screen. Then, instead of showing the address ID for the customer, it would be more useful to show the details of the customer's address here, such as the street address, the city, and the country. Finally, instead of showing the link to open the customer details screen on the first column store ID, we may want to move the store ID to the right and have the link on the last name, which would shift left. It may sound like a handful of changes to make, but you're about to see how easy it is to make them with Zomega. If you look at the default CRUD operations that we added to the customer entity, you'll see that it includes a read list operation, which is what the customer list screen is based on. Specifically, the columns in the results grid are based on the output parameters of that operation, as they are added to the customer list data object. So now I just need to set our output parameters based on how we want our result grids to look like. First, I'm going to remove the active and last update parameters, which will drop the corresponding columns. Then I'm going to move the store ID parameter down before the active bool and move the last name parameter up before the first name. Next, I'll remove the ID from the address ID parameter to turn it into a street address. Because this parameter no longer matches any field on the customer object, Zomega cannot infer its type, so we have to specify its logical type explicitly. In a similar manner, I'll add 2 extra parameters for the city and country of the customer's address, including their logical types. For the final touches, we'll want to update the header for the active bool parameter and change the details link to be on the last name instead of the store ID. This can be configured on the customer list data object, so I'm going to go to the definition of that data object and expand it. The UI display for each field can be configured in the display section. For example, you can see that the internal customer ID parameter was pre-configured to be hidden, but we still need it in the output to be able to open customer details. So I'm going to add the active bool parameter here and configure it to use the label active for the column header. This will actually generate a resource file, which allows you to localize this text for different locales. Now, to make the link for opening customer details screen displayed on the last name rather than on the store ID, I'll expand the details link here and change the on-field attribute of the display element to be the last name. Those are all the changes that we need to make to our model. So I'll go ahead and build the model project to regenerate all the artifacts from the updated model. If you open the generated implementation for the customer service and go to the read list operation, you'll see that it returns the updated result fields now. Well, at least it tries to. Because it doesn't know where to source from the values for the custom parameters that we added, it just added commented out placeholders with to-dos, instructing you to set these values manually in the code. The really cool thing about these comments is that all your custom code will be preserved when you regenerate this class, as long as you put it in between the custom code start and custom code end markers. Since the entity classes for our objects have been generated with all their referenced objects as properties, we can just use the address object on the customer entity, as well as other related objects to populate our custom fields. And that's really all there is to it. Let's hit F5 to build and run our updated app and take a look at what we've got. I'm gonna log in, open up the customer list screen, and click search. As you can see, we have the results grid columns exactly the same way we specified them in the output parameters of the read list operation. Instead of the address ID, we see the address details that we populated in the custom fields. The link to the customer details screen is now displayed on the last name column, and the active bool yes/no column uses the label active that we set as the header. So now that we've seen how you can change the default CRUD operations to build the screens that we want, let's see what happens if you need to change your domain model based on some new requirements, and how Zomega helps you apply the domain changes to your PostgreSQL database. If you remember, on our customer list screen, we displayed the customer store ID as one of the columns. Normally though, it would be better to show something more user-friendly to indicate the store associated with each customer. However, for some reason, the store object in our sample database doesn't really have any identifying user-friendly field to display there. All it has is just a bunch of IDs and the last update timestamp. So why don't we go ahead and add a new field that I'll call store name. Typically you want to define a dedicated logical type for this, but for simplicity I'll use one of the existing imported types, string20. I'm also gonna make it required to show you what happens when you add a required new column to an existing table. Before we update the database, let me show you how to display a user-friendly name instead of the internal ID for a static and small list of objects, such as our list of stores, which has only 2 records in the sample database. To enable that, we'll add a read_enum operation to the store object that returns key data for all stores, which can be cached in memory and used to convert internal IDs to display names and vice versa. Luckily, we already have a generator that can add such a read_enum operation that returns all object fields. It automatically configured the enum for caching and set the output parameter that is used as the internal ID, as well as the one that will serve as a user-friendly description. It also associated the key type with the new store enum and made it based on the integer enumeration type, which helps you to work with such cached values and to edit them with selection controls, as you will see later. So now, how do we upgrade our PostgreSQL database with the changes we've made to our domain model? Zomega provides a couple of generators that can help you create an SQL script to either create all the tables from scratch, such as when you want to create a new database for another environment, or a script to update the existing database based on the changes in your domain model, similar to Entity Framework migrations. Let's run the database schema generator to take a look at the full SQL script it creates. By default, the output path is in the same project, so I'm going to show all files and open up the generated file. As you can see, the SQL script creates PostgreSQL specific things, such as the sequence for the film ID, a domain for the year type, and an enum with values for the film rating. You can also see that it added to the store table our new required character column store name of maximum size 20. If we just want to update our existing database that we imported our model from, then we can run the database change script generator. If I refresh the project and open the generated script, you'll see that it contains an alter table statement for adding the store name column. Because the new column is required, it used an arbitrary string as the default value and provided a to-do comment for you to review that default value and update it as needed. The default is then being dropped, but you can add your own statements to properly populate the values in the new column. You can also make the generated script rerunnable, so that you could run it at any time without worrying if it's already been applied to your database. If I regenerate the script, then you'll notice that it added the PostgreSQL clause if not exists to make the script rerunnable in this case. The syntax errors that you see here are because Visual Studio opened our SQL script using Microsoft SQL Server data tools, which does not work with PostgreSQL. Therefore, to run this script, I'll go ahead and open it in the pgadmin tool. As you see, it shows no syntax errors now, so I can go ahead and execute it by hitting F5. The console shows that it was executed successfully. Since we made it rerunnable, I can execute it again, and it just tells us that the column already exists without throwing any errors. Let's view the content of the store table now. As you see, it has our new column store name populated with the default value that we specified. To properly populate the store name, I'll add a couple of update statements, where I'll assign the first store a name main and the second store a name other. Let's run the update statements and then rerun the select query to verify that the data is now correct. Perfect, just the way we want it. This will allow us to show these store names instead of the internal store IDs on the customer list screen. If you remember, that was enabled by the read enum operation that we added to the store object, which also updated the store type to reference that enum. So any other field that uses the store type or its subtype will automatically use this enum, in addition to creating an implicit reference to the store object. However, for some weird reason, the customer store ID column doesn't have a foreign key reference to the store table in our sample database. Therefore, its type was defined as just small int that doesn't inherit from the store type. So to make the store ID field use our enumeration, I'm going to define a new type, customer store, which extends from the small int enumeration and references that enum. And then I'll use that type on our store ID field. Finally, I'll go back to the customer list data object and we'll change the label for the store ID column to read just store, just like we did for the active bool parameter. Well, now let's build the model project one more time to regenerate all the artifacts and then hit F5 to run the solution and check out our updates. Let me open up our customer list screen from the navigation sidebar. Just like with other generated list screens, we have a search criteria panel that allows us to show only the customers that match certain criteria. For example, I can search for customers whose last name starts with Joe. Once I hit search, you'll see that it shows only 6 matching customer records and the summary of the applied criteria right above the search results. The customer address fields still show the right values, which means that our custom code has been preserved when we regenerated all artifacts. Now notice that instead of the internal store ID, our customer list automatically shows the values of the store name that we added to the store object. If you open details of one of the customers, you can see that the store ID field is now edited with a drop-down list that shows the store name and saves internal store ID in the database. If I change the store on this customer to other, you'll notice that the view title got an asterisk, indicating that it's now modified, and the save button lit up. Once I save my changes, the asterisk goes away and the save button becomes disabled again. Notice also that the value of the customer store was automatically refreshed in the original results list. Perhaps you can see it better once I close the details view. While there are plenty of other Zomega features that help you quickly model and build your business applications, I hope that this video has given you a good idea of how to import your model from a PostgreSQL database, generate basic search and detail screens, and customize them as needed, including enhancing your domain model and updating your database. To learn more about Zomega, please visit our website zomega.net, where you can download and order a free version, read detailed documentation, or follow our complete step-by-step tutorial. Also make sure to subscribe to our channel and follow us online for any additional videos and updates. And please drop us a comment below on what you think about our technology or contact us with any questions. Thanks for watching and see you next time.